Okay, we were looking into sequences, and today I would like to focus on what's called a recursive sequence. Recursive sequence. Now, recursive sequences are very common in a lot of different areas, including computer science. What do we mean by recursive sequence? Basically, recursive sequences, or in recursive sequences, we need to know the previous term to generate our next term. So the next term is generated by the previous term. Now, if you notice if you remember our sequence of odd numbers, 1, 3, 5, 7, etc. And if you remember that our algorithm was 2n minus 1. So to get the first term, we just needed to plug 1 for n, and that would be 2 times 1 minus 1, which equals 1. To get the 10th term, we can just find the 10th term using this algorithm here. So that's going to be 2 times 10 minus 1, which is going to be 19. But that is not true for recursive sequences. For recursive sequences, we actually need to find the 10th term, a sub 10. We need to know what a sub 9 is, what the 9th term is. And to find a sub 9, we need to know what a sub 8 is. To find a sub 8, we need to know what a sub 7 is. So you see where this is going. To find the next term, you actually have to find the previous term and work from there to this term. And then to find the previous term, we need to find the term before that to find this one. So you'll notice if you go all the way like this, let's say we got to a sub 1. Well, to get a sub 1, you might be assuming that we need a previous term here to get a sub 1. But this is where the recursion usually stops. So we usually need an initial value for recursive functions. Initial value. And from this initial value, we can generate our next value. And then from our next value, you can generate the next value, and so on. So let me give you an example of a recursive function. This is actually a very famous sequence. It's called the Fibonacci sequence. I'm sure some of you have heard of the Fibonacci sequence before. And the Fibonacci sequence is a recursive sequence. So because it's a Fibonacci sequence, instead of using a sub n, I'll use a f sub n here. So to get our nth term, we need our two previous terms. So n sub f sub n minus 1 and plus f sub n minus 2. So we need our two previous numbers, to find our next number. So that means in the beginning, when we are starting this Fibonacci sequence, we need two initial terms. So let's say our first term is 1, and our second term is also 1. So now these are all given. All of this is given. And we need to generate the next term. So to get f sub 3, our third term, remember our n is 3 now. N is 3. So that means if you plug in n here, that's going to be f sub 3 minus 1 plus f sub 3 minus 2. That is going to be f sub 2 plus f sub 1. Okay, so we are adding f sub 1 and f sub 2 to get f sub 3. We know that f sub 1 and f sub 2 are both 1s, so that is the same as They're both 1s here. So we're just adding 1 plus 1 and get 2. So when you're working with recursive functions, it's very important that you keep in line what our previous values are. So remember, our f sub 1 and f sub 2 values were 1s. And now our f sub 3 value is, we added those two and we got 2. Okay, so we need our list of previous terms in a recursive function. Let's try and find f sub 4. Our fourth term. Our fourth term is going to be f sub, again, we're using this algorithm here, 4 minus 1 plus f sub 4 minus 2. That is going to be f sub 3 plus f sub 2. And looking at our list here, f sub 3 is 2 and f sub 2 is 1. Okay, so our fourth term is going to be 3. It's going to be 3. How about our fifth term? Fifth term is going to be f sub 5 minus 1 plus f sub 5 minus 2, which is going to equal f sub 4 plus f sub 3. And we can see that our f sub 4 here is 3, f sub 3 is 2. So we add those two, we get f sub 5 is 5. So this is how you work through a recursive function. You need to know the previous terms to get our next term. So it would be very easy for you if you write this, the list of previous terms. This looks like a 21 and a 31. It's actually not 21, 31. You need this list of numbers. And it's going to be much easier if you have this list of numbers to get our next term. So this is an example of a recursive function, and it is actually a very famous sequence, or not recursive function, a recursive sequence. This is a very famous sequence called the Fibonacci sequence. Keep this name in mind as it will show up later on. Okay, so let's try another example with a recursive function. So let's say we have that our function is a sub n equals 2 times a sub n minus 1 plus 5. This is the algorithm for a recursive sequence. And remember, for a recursive sequence, we can't just have this. Actually, let's try and work with just this. So let's say we want to find a sub 2. A sub 2. That is going to be 2 times a sub n, which is 2, minus 1, plus 5. That is going to equal 2 times a sub 1 plus 5. But we actually don't know what a sub 1 is. And when you try to find a sub 1, it's going to be 2 times a sub 1 minus 1 plus 5. Which equals 2 times a sub 0 plus 5. And now we don't know what a sub 0 is. So for recursive functions, I've said this before, you need to have the initial value. So for this problem, our initial value, a sub 1 equals 3 is our initial value. So you need to have these two things. You need to have the algorithm and the initial value for recursive sequences. Okay, so now let's go back to finding our a sub 2 here. We know that a sub 1 is 3. Now we know that a sub 1 is 3. So we can just substitute in 3 for a sub 1 here. So that's going to be 2 times 3 plus 5, which is going to be 6 plus 5, which is 11. Okay, so again, keep a list here. A sub 2 is 11. Now let's try a sub 3. A sub 3 is going to equal 2 times a sub 3 minus 1 plus 5. That is going to equal 2 times a sub 2 plus 5. And that is going to equal, a sub 2 is 11. Okay, see how it's helping us when you're listing all the previous terms? 2 times 11 plus 5, which is going to be 22 plus 5, which is 27. So you can find your next terms this way. A sub 3 equals 27. And like I said before, it's very hard to find the 100th term, let's say. To find the 100th term, you need to find the 99th term. So that's going to be 2 times a sub 99 plus 5. And then to find the 99th term, you need the 98th term. So for recursive functions, it's going to be very hard for you to find, at least with this algorithm that we have, with this algorithm, it's going to be very hard to find the nth term. However, for some recursive sequences, we have what's called the closed form. And the closed form for a recursive sequence is an algorithm. It's different from this algorithm, but it lets us find the nth term. So for this same sequence, the closed form is actually 2, or a sub n equals 2 to the power of n plus 2 minus 5. And notice we don't have an a sub n minus 1 inside our algorithm. So this means now we can find a sub 100 simply by plugging in 2 to the power of 100 plus 2 minus 5, which is going to equal 2 to the power of 102 minus 5. This is going to be an extremely big number, so I'm not actually going to calculate it. But some recursive sequences have this kind of closed form. So with this closed form, you can find the nth value. So we're not going to cover how to get the closed form algorithm. That is much more complicated. But just remember that if we have a recursive sequence, normally we need to have all the previous terms to get our next term. But with this closed form, we can bypass that rule and find the nth value. For now, just remember what recursive sequences are and how to generate a recursive sequence from a given algorithm like this.